Hi, this is K. Pawan Kumar from Triple Department. In this video, I want to explain about Rangi-Kutta method of second order. Firstly, we can see the notations in Rangi-Kutta method second order. So let us consider dy by dx is equals to f of x comma y with an a boundary condition y of x naught is equals to y naught with step line function h. Then the second order of RK method can be defined by y1 equals to y naught plus 1 by 2 into k1 plus k2 is equals to y of x1, and here k1 is equals to h into f of x naught comma y naught, and k2 equals to h into f of x naught plus h comma y naught plus k1, and here h is equals to x1 minus x naught. And similarly y2 is equals to y of x2, y1 is equals to y1 plus 1 by 2 into k1 by k1 plus k2, where k1 is equals to h into f of x1 comma y1, and k2 is equals to h into f of x1 plus h comma y1 plus k1. So see that problem. Using Rangi-Kutta method, solve the differential equation dy by dx is equals to y minus x. Y of 0 is equals to 0, and find y of 0.1 and y of 0.2. A solution. Here the solution for the above problem. Firstly, we can consider the given differential equation dy by dx is equals to y minus x. Let it in functions f of x comma y is equals to y minus x, and the given boundary function is y of 0 is equals to 2, and compare the y of 0 is equals to 2 with y of x naught is equals to y naught, and then we get x naught equals to 0, y naught equals to 2, and the given data x1 is equals to 0.1, x2 is equals to 0.2, y1 and y2 are we want to find that, and h is equals to x1 minus x naught. Here x1 is equals to 0.1 and x naught equals to 0, and the result of h is equals to 0.1. By Rangi-Kutta method, of the second order, y1 is equals to y naught plus half of k1 plus k2, and k1 is equals to h into f of x naught comma y naught. Here k1 is equals to h is equals to 0.1, and from the given differential equation we can write here f of x naught comma y naught is equals to y naught minus x naught. So here it will becomes 0.1 into 2 minus 0. So k1 value is equals to 0.2, and k2 is equals to h into f of x naught plus h comma y naught plus k1, and k2 is it's equals to 0.1 into f of 0 plus 0.1 comma 2 plus 0.2. k2 is equals to 0.1 into f of 0.2 comma 2.2, and the final value of k2 by substituting these all values is k2 is equals to 0.21. So we determined k1 and k2 and then substitute in y1. y1 is equals to y of x1 is equals to y naught plus 1 by 2 into 0.2 plus 0.21. By calculating this value, we can obtain 2.205, which is the value of y1. And then similarly, y2 is equals to y of x2 is equals to y1 plus half of k1 plus k2. Here k1 is equals to h into f of x1 comma y1. H is as usual 0.1, and here x1 is equals to 0.1 and y1 is equals to 2.205. We already determined it, and here we can substitute this in k1. We can get the value 0.2105, and k2 here it's equals to h into f of x1 plus h comma y1 plus k1. Here we can consider K1 as in this K1 is above value. Here we can consider the K1 value which is the obtained in above step, and K2 is equals to 0.1 into 2.4155 minus 0.2. It's equals to 0.22155. And the y2 value is equals to, by substituting k1 and k2, 2.205 plus half of 0.2105 plus 0.22155. Y2 equals to y of x2 is equals to 2.421025. This is the brief explanation about Rangi-Gupta method of second order. Thank you for giving this opportunity.